Hello folks, today's mission is, as you can probably see here, going to be a long and boring talking video. What I'm hoping to do today is to focus on the Lexus GS450H system. I'm going to talk about how it works, how our controller works for this, the parts that you're going to need to get this to operate in an electric vehicle conversion project, and we will then hopefully know more by the time that we finish here in this video. Now I will again warn you, this is going to make reading the instruction manual for a cement mixer look like a fun day out. So you have been warned. Okay, so I guess we're going to have to start somewhere. So I guess the somewhere is going to be why are we talking about this system at all? Well, most of this, for me anyway, started well over 5 years ago when there was a guy on the DIY electric car forum that had undertaken a conversion using, instead of a motor, but using basically this thing, which for all intents and purposes looks pretty much like an automatic gearbox. And indeed, back here in the tail shaft area, that's kind of exactly what it is. It is an automatic gearbox that has a 2-speed hydraulic planetary system that is electrically shifted. But it's got a rather more going on in here than the average gearbox. And if we just pick, and I'm just picking this particular eBay listing completely at random just because it's the easiest place to get photographs of this thing to show you. We'll go into some of the places you can find them later on. But you're going to notice straight away that there's these two orange cables. And in hybrid and electric vehicles, this particular color of cable pretty much donates that there's a high voltage current going to be flowing through what is contained within. So let's see if we can get a little bit of a closer look here. And I'm sorry about this stupid pop-up bar thing at the bottom here, but you're going to see there's another little signal connector here and a signal connector here. And these will become important later. You can see this thing, it looks like a coolant point here also, and there's this kind of a bolt-on plate that may contain something like, oh, I don't know, perhaps an oil to water heat exchanger behind it. Down here at the tail shaft end, we've got pretty much another little connector here that would have a output shaft speed sensor. There's a grey connector here that might be the connection for the solenoids for shifting the 2-speed gearbox in here. If we click through some of these pictures here, you'll see that, you know, it's got pretty much a kind of a gearbox output flange to a propeller shaft. It's got back here around the back cross member mount, so very gearbox like. Now up the front those that may be familiar with automatic gearboxes will kind of see this is where things begin to take a little bit of a turn for us. And that's because rather than there being a traditional input shaft here and the pump drive and stuff, we've just got this spline shaft here that's, you know, fully bearing supported, and there's no separate pump drive as you would have with a traditional hydraulic planetary automatic gearbox. So let's move on. On the other side, we'll see again that there's these two orange cables, and they've got these large plugs on them. And down here, you've got a mechanical shift linkage bar, so that would go to a traditional, you know, park, reverse, neutral drive shifter. You'll see that there's something should be bolted to this flange that is missing. We'll get to that later, but it's just worth making a note of that now. And there's another coolant hose here that, as we say, is for a oil to water heat exchanger. So this is a liquid cooled system. Sorry about the flickering here, it's just going to be a subject of just me using these eBay pictures. We're not going to be around here for much longer, so don't worry. So just scrolling around it, you know, it pretty much, if we were to take those cables off, you'd be forgiven for thinking that what you've got here is just a normal automatic gearbox. Now, this is the car that you would typically find that particular gearbox in. It is the Lexus GS450H, which is a four-door saloon car, nominally powered by a V6 petrol engine. And when we remove that petrol engine, we're left with the gearbox that contains not one but two electric motors. And in this rather low quality picture, we can see what goes on inside that gearbox. Now, I'm not going to go into huge details on this, but we just want to get familiar that what's inside this casing is not just a bunch of bands and clutches like you would find in a traditional automatic, but rather what we have is a very capable electric vehicle drivetrain. So you'll see up here in the front bell housing area, where you'd normally like find a torque converter, we have the first electric motor. This is the bit in the middle that rotates, and these are the windings where we inject electricity. And this is called MG1 for motor generator number 1. Now in the middle here, in this little section, we have what Toyota call the power split device. In this case, it is a planetary gear set, and linking into that planetary gear set is this much larger motor here. Again, this is part that rotates. This is our this is our rotor because it rotates, and this is the copper windings here where we inject our electric current to make the motor rotate. Back here then we have our 2-speed hydraulic planetary gear set, and that finally goes out here to our propeller shaft. So this is what's inside the casing, folks, and in a lot of ways this is what has made this such an attractive and capable powertrain. And the kind of icing on the cake for it is that there are literally millions of these things out there, and they are getting cheaper. And so far, the testing that I have done personally on this reveals that a lot of the myths out there about, you know, what it can and can't do and what one would need to do and maybe not need to do are, shall we say, not exactly true. So again, don't worry about the prices here or this stuff. I'm simply using eBay as an illustration tool here to let me show you the various bits that we would need to obtain. So basically what we get here is we get the motors and the gearbox all in one. But then we need something to make the motors turn, and that something is called an inverter. And this is the inverter that we would require to connect to that gearbox. So it's basically, let's see if I can click on this for you, get some more screen flickering going on. It's basically a box. And you'll see here on the front that there's these two large ports. And those large ports are where we connect the cables that come from the gearbox. So these, let's click in on this. So these orange cables that have the plugs on them plug into these two ports on the inverter, and you've got these tapped holes here where conveniently you see these little bolts can bolt into. This box contains all the power electronics that you need to convert DC current from a battery into the alternating current to run both motors. You do not need two of these inverters. There are in fact two separate power stages in here, because we can see that by the fact that both of these three-phase AC power cables plug in to the one inverter. This is additionally a liquid cooled item. So you see we have one coolant port here, and let's see if we can get some other angles on this for you. There's a close-up on the AC connection ports. That's the data connection or data connector, which we will be getting to soon. Let's see what else. Got some part numbers. Yeah, so there's a side view. So again, this is where our power cables from the gearbox connect, where we can send power to those two electric motors. This is where we connect the control signals to tell this what we would like the motors to do. So there we'll see there's the second cooling port or part numbers, and that's it for this one. Okay, let me get rid of screen flickery here for you. So we now have a gearbox, which is actually a dual motor drivetrain system. We have an inverter, which will allow us to drive them, to make them turn. So we're going to use, just to reiterate this, let me go away from screen flicker mode, hopefully. We're going to need one of these, and we're going to need one of these. So you might reasonably ask at this point, why are there two motors in here? Why do Toyota have two motors? And the reason that they do that is in the traditional internal combustion engine setup here, where there'd be a big V6 bolted onto the front here. The function of the two motors is not primarily to, I suppose what's the phrase, is not primarily to drive the vehicle. They are what they call an ECVT, and I suppose an electronic continuously variable transmission. So the engine power comes in through this spline shaft here, and it can turn MG1. MG1 is additionally used for engine starting. We have a very small battery in the GS450H in the region of, I think, about 1.8 kilowatt hours. That's just a measure of how much electricity that it can store. And that power is transmitted from the internal combustion engine coming in here outwards to the propeller shaft to make the vehicle turn by means of the interaction of these two motors and this power split device planetary gear set, and obviously the 2-speed hydraulic planetary transmission here. As a side effect of that, there is a very limited capability within the GS450H vehicle to operate in electric vehicle mode. It's severely limited. It's like, I think it's up to about maybe 10 or 20 miles per hour for, I think probably a mile, if that. And that is accomplished by the use of MG2 alone. So just MG2 can take power from the battery, turn that into rotation, send that out to the propeller shaft without turning the internal combustion engine. So that's the means of this planetary gear set allows the internal combustion engine, MG2, MG1, and the propeller shaft output to operate in various configurations. Again, I'm not going to get too bogged down in the detail, but I want people to understand why there will be two electric motors in here. So that's the first thing that you need to understand. Now, how then, you might reasonably ask, does this present itself as a traction system for a purely electric vehicle? Well, there's a bit of a trick to this, and it's in two parts. If we were simply to take the gearbox as you see it, here, with nothing connected to the engine engine input shaft here, and if we were to apply power to these motors, if we were to apply power to just MG1, all it would do in this case will be to spin this engine input shaft here. It wouldn't be able to send useful power down here to the propeller shaft flange. If we were to do the same thing to MG2, it could indeed send useful power back out here through the propeller shaft flange. Now, there's a means here that we can trick this power split device to get it to allow us to send power not just from MG2 to the output shaft, but also from MG1 to the output shaft. And that is by the very simple procedure of locking this engine input shaft and not allowing it to turn. So if you can imagine that we were to put something onto those splines here, and we were to bolt that to the bell housing, like if we put a plate on there or a bar, and had a spline fitting onto this shaft here, then if we apply power to MG1, it cannot turn this shaft here. So that is going to then force it to send torque, power, rotation, whatever you want to call it, back down here through the power split device into MG2, and by virtue of it turning MG2, it will continue this way through the two-speed gearbox system and out to the propeller shaft. So if we remove the internal combustion engine from the equation completely, replace it with a means of locking that input shaft in position, we can now not just use the power of the MG2 motor to rotate the propeller shaft, but both of them. And we get a little added bonus in here. The gearing ratio that we get between MG1 and MG2, I think, don't quote me on this, is something in the region of 2.6 or 2.7 to 1. So what that means is that for every rotation of MG1 rotor, it will cause the MG2 rotor to rotate 2.7 times or something like that. I'm not honestly sure of the exact ratio. And that then lets us use both of these motors to send power out to a propeller shaft into a differential, and thus make the wheels of an electric vehicle conversion turn. So if you have stuck with me for the currently 23.5 minutes that I've been blabbering on here, you might now be having some questions. And this is where usually I guess I can call them the internet myths start to seep in, and people I guess just fall away because they see this as being this horrifically complicated method, and they start believing a lot of the things that go on or that get said. So I want to address a few of these things here immediately before we get into the rest of the detail about what we're going to need, because we need to get these myths out of the way here. And I'm going to make this little document as we go, and I'll stick this up probably on GitHub, so you'll be able to grab it once we get this horrifically long video finished. Now, the first myth that we get is system voltage. Okay? And what I mean by system voltage is that if we look at the battery voltage that's used in the GS450H, is a 288 volt battery. Okay? That is a fact, and I'm only going to deal in facts in this. There will be no repetition of stuff that I've read online or calculated from some random thing that I've picked up on some forum or social media or something. This is stuff that I've measured, observed with my own senses. Obviously there's going to be gaps in this because there will be things that I haven't measured and seen with my own senses. So I would ask people not to fill in those gaps with things that they have not verified for themselves with test equipment and with their own senses. So, enough of my ranting. We have a 288 volt battery. Now, myth number one here, right, is that, I'm going to type this out, myth number one, you need 650 volts to run the GS450H gearbox. Okay. There's this scene from, I think it was Airplane, that comes to mind, but I won't repeat it here because it's rather vulgar, but I always see this. Where does this come from? Okay, so before we deal with it, we need to know where this actually comes from. So what we're going to do is we're going to jump to the Open Inverter wiki page for the GS450H inverter. We're going to jump down here to, and there's quite a good description of the inverter here. And basically we're going to focus in on this. So what we say here is we have two high power inverters, as we say, because we've got our two motors in there. So this is what we're talking about here. Is we're talking about this box, okay? The box, the inverter, the whatever you want to call it, the thing that makes the motors turn. Now, oh, I'm going all over the place. All right, so it has, one of the things that it has in there is it has a boost converter. It's actually a buck boost converter. So what the hell is that? Well, that is a piece of power electronics that can take a voltage of one magnitude in on one side and give you either a higher or a lower voltage out on the far side. And what we say here is that there is a boost module to boost the 288 volt battery pack up to 650 volts. So this is where the 650 volts figure comes from. So then if we read this and we say, hang on a sec, well, there's a boost module in there to bump this battery up to this. So therefore, this is where this comes from. We then make the leap that you will need 650 volts to run the GS450H gearbox. So that is patently, demonstrably incorrect. Okay, I'm going to repeat that. That is incorrect. Now, I haven't guessed this. I haven't read this somewhere. I have gone and put one of these frigging things in a car and proven it. And yet the myth persists. So let's break this down a little bit further. We need to understand just a little bit about how a motor works. And don't worry, there's going to be no maths here because I am absolutely hopeless with maths. I couldn't I couldn't add 2 and 2 without getting 5. So a motor works on current, not voltage. Okay? But to drive current, you need voltage. Okay? That's part 1. That makes sense? We can't push current with no voltage. So we need some voltage to push the current into those copper windings to make the motor turn. As the motor speeds up, it starts to generate a resisting voltage to the current in the windings. This is called back EMF. We can say EMF is equal to volts, voltage. So the motor pushes back against the battery as it speeds up. Okay? Simple, right? So what does this mean? Well, let's go back to the myth. 650 volts. So therefore, let's do some extrapolation. If the motors are going to push back against the battery voltage as they speed up, then the problem must surely be that the way these motors have been designed, they will not reach their full RPM unless we have 650 volts of battery voltage available. Wouldn't that be a reasonable thing to say? Sounds like that. Yeah, it is. And that part is probably true. So what this should really say, what it... Oh, I'm making a mess here. What it should say is you probably need 650 volts to get max RPM under full load. That would be true to say. Probably. I don't know. I haven't tested it. Nobody has bothered. They just go right out and believe this part. So, what happens if we run at a lower voltage? Say, oh, I don't know, 360 volts, like most electric vehicle batteries run at. Let's find out, as they like to say. So, fortunately, this strikingly handsome gentleman here decided to do just that. What you are watching here is a BMW 7 Series E65 with the Lexus hybrid gearbox that we've been discussing in it, running presently with a system voltage of 393 volts, as we can see here in this window. This window here is a representation of some parameters that are being monitored by the control system. So I'm going to pause this here for a sec. We'll be discussing the control system soon, but what I want to do first of all is to really get rid of this 650 volt myth, hopefully once and for all, but probably not the way things work. So right now at this particular freeze frame, I want to talk to you about what's represented here, because some people have watched this video and they've drawn incorrect conclusions from it. And this seems to be one of my, this seems to be one of the things that happens to me, that every time that I think something is incredibly crystal clear, it turns out not to be. So right now, there is a battery pack voltage of not 288 volts or not 650 volts, but rather 380 volts being applied to the inverter. Remember the box that we showed you on our Flickery eBay page. This exact moment in time, there are 29.9 amps being drawn by the inverter at this voltage, resulting in a power of 11.41 kilowatts. Presently, MG1 is turning at 1,825 revolutions per minute. MG2, which is the bigger motor, is turning at 1,512 revolutions a minute. The temperature of the stator of MG1 is at 11 degrees centigrade. This was shot several months ago before the virus lockdown. And the MG2 temperature is at 11 degrees centigrade also. This one here is a representation of the oil pump drive, which I will discuss later. I don't want to complicate things too much. I want to try and at least get this about, you know, hour and a half long, hopefully. Okay, so I'm going to just let this video play on, and I'm going to try to, actually I won't do that, hang on one sec here. Okay, so at this point now, we are accelerating out onto a motorway where the speed limit is 120 kilometers per hour, or just over 70 miles per hour for oldies like me. Now I'm pressing the throttle, not particularly hard, but I'm pushing it. And as you can see, we've got a few changes on our gauges here, and I want to slowly describe to you what we've got going on here. Our battery pack has sagged from about 380 volts down to 267 volts now, because it's a crappy old battery that I'm just using to test this vehicle and test the Lexus drivetrain. Because keep in mind, folks, this guy sitting here, as he was getting into driving the car, was actually believing a lot of that crap, that, you know, this wasn't going to drive particularly well or particularly fast. So the battery voltage has sagged as a result of the fact that we're drawing at this point, in this exact capture here, 450 amps, or about 118 kilowatts. At this point, MG1 is turning 4,902 revolutions a minute, and MG2 at 4,064 revolutions a minute. Now, the top limits for the motors, I believe, are either 9 or 10,000 RPM. I'm not 100% certain. but it's something in that region. And I've stopped here because this is a very, very, very important clip. What this is showing us is that at 4,000 RPM on MG2 and at 5,000 RPM on MG1, with only 267 volts available, we are pushing 450 amps or 120 kilowatts of DC power. This is power measured from the battery going into the inverter. And we are pushing that power into MG1 at 5,000 RPM, call it, and MG2 at 4,000 RPM. So we are nowhere near the point where even the 267 volts is insufficient to push this level of power into the two motors turning at this speed. I'm going to repeat that. At 267 volts, we still have enough voltage to push 450 amps of current, giving about 120 kilowatts of power, or about 140 horsepower or something like that, into MG1 at 5,000 RPM and MG2 at 4,000 RPM. So, let's get back. Oh, stop driving. Let's get back to our myth here. So, what we can say from actual measurements is at 267 volts, we said MG1 approx 4k RPM. No, sorry, MG1 I think, what was it? MG1 approx 5k RPM, MG2 approx 4k RPM. We are still pushing approx 120 kilowatts. So have not ran out of voltage. That is a measurable, demonstrable, and repeatable fact. I'm sorry that it doesn't agree with something that maybe you've read somewhere or someone has told you or you've convinced yourself of or whatever. I can't help you with that. I can only report what I've observed. So that is our first hurdle over. I don't expect this argument to be finished, but what I do expect is people to get past it. You can watch that video as many times as you please, but that is fact. I have not fiddled it. I've not done anything else to it. Now, next up, so we need to do the next myth here. I'm only going to do two, so don't worry, because these are by far and away the biggest ones. So let's see if we can do a little bit. I'm useless at this. I never figured out how to use any of these things, but we can make that red anyway, so I suppose that looks a bit better. Okay, myth number 2. So how do we say this? Oh yeah, very simple. It will overheat very quickly, as it was not intended can I even spell? Yes, can I spell? Intended to run as a pure electric vehicle. Oh well, I guess that's it then. I guess we're done. Because if you recall what I said, the gearbox is indeed supposed to act as a transmission, not necessarily as a means of powering the vehicle. So let's address this. Alright, so I have open here the Wikipedia page for the Lexus GS. And if we come in here and we look at the powertrain, we're going to see that the powertrain for that vehicle is the Toyota 2GR FSE V6. So I'm going to click on that. So the 2GR FSE is a 3.5 litre engine using these various vehicles. Here, where's it gone? I mean, the engine achieves specific power on top of all. And blah, 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 blah. So here we go. 234 kilowatts or 314 horsepower. So yeah, so about 300 horsepower or something like that. We don't need to know any of this crap. Oh, hang-ups. The Atkinson cycle one. Here we are. Sorry. This is the Atkinson cycle engine. Okay, so it produces 218 kilowatts or 292 brake horsepower. Now, what did I say? I said that 292 brake horsepower gets pumped into that gearbox and it has to come out the far end. And in order to do that, in order to make that electronic continuously variable transmission thing, it uses the two motors in combination with the gearing to deal with that power. So that power has to be dealt with. So there has to be the ability within the gearbox to deal with that power. That is just a fact. I'm not saying anything else. I'm saying that power of that engine, okay, in that car has to go into the gearbox and it has to come out of the gearbox, and it's got to do that all day long. Like, I could get in this car, fill it, drive it, fill it, drive it. I could have 4 guys in the back taking turns. We could just keep driving this thing until some part of it fell off, okay? And it's got to be able to handle that power continuously, okay? I don't mean that full power all the time, but it's got to be able to deal with that. Okay, that's a fact. All right, so back to Flickerland. We spoke about the cooling. So this has got coolant, so normal glycol coolant. We get pumped in here round the heat exchanger where it cools the transmission fluid and comes out the far side. If we look at the other side of the gearbox, I want to draw your attention to these 2 bolts here. These are actually plugs. In certain versions of this gearbox, I haven't figured out what the versions are. I have 2 of them. One of them has just got the bolts here, but the other one has got banjo connections. And those banjo connections come to a pair of steel hard lines that come down here and sneak up to the front of the gearbox around here. And they would connect to a transmission oil cooler that would be mounted up in the front radiator pack. So now all of a sudden we have the ability to water cool it and also oil cool it. And I'm pretty sure if we took those plugs out, we could connect up a couple of banjo fittings and some hydraulic lines and convert this to convert this to having both oil and what's the word for it, glycol coolant also. Now we have to unfortunately come back to this particular drive here. There's a 15-minute video that I shot just before lockdown when we were taking the car to its inspection and back. Total journey, I would guess I think I might have mentioned it in the video even, but I think it was probably like 10 miles, I'd say, something like that. Pretty much I'd say maybe 60% motorway, 40% slower roads in a big E65 7 Series. You will note now that we've gone from 11 degrees centigrade at start to 15 degrees centigrade on our temperatures here. So what I want to do is I want to jump forward and see when we were finished to drive here and see exactly what the temperatures were. So this is me pretty much almost finished, I think. Here am I? Yeah, pretty much finished with a finishing temperature of 21 degrees centigrade. So we climbed a total of 10 degrees on that entire drive. And that was using both of those motors to propel the car. Now, that is the only factual data that I have that I can share with you at this particular time. But, oh, and by the way, in this case, I'm not using the oil cooling, just the glycol cooling. So I have the two, I've got the two hard lines simply looped with a hose. So there's no separate oil cooling, I guess would be the way to say it. So that's what we get, folks. Will that trend continue? I don't know, but that gives me, sorry, I'm going all over the place again. That gives me enough evidence to be able to say to you, I've gone and screwed myself up. That gives me enough evidence, okay, to be able to say to you that I think we're going to be fine. If someone can provide measurable, factual evidence to me that we're not, then I'll certainly pay attention to it. But I won't be paying attention to anyone that just decides because they've figured something out in some weird way that it's not going to work. So, okay. We mentioned, and it's time now that we move on to the next one, which is the oil pump. Okay, so remember in this picture here that I asked you to pay attention to the fact that we've got this little flange here that looks to be missing something. Now the thing that it's missing is the external 12-volt electric oil pump. Now, let's back up a little and ask ourselves, why would there be an external 12-volt electric oil pump? Well, the GS450H gearbox has in fact got two oil pumps. We need to pressurize the transmission fluid for two reasons. One is to get it to physically move around inside the gearbox so that it can perform cooling, because our motors and all are basically cooled by the transmission fluid. The second is we do have that 2-speed hydraulic planetary back here, and that needs pressurized transmission fluid to move its clutch packs. So when the engine is running, we have a gear pump that's driven from that input shaft that we were showing you. So there's a little shaft that runs back through the gearbox that turns a little gear pump and provides, if memory serves me, about 120 psi of pressure. Now the vehicle does have very limited capacity, as we explained, to run as an electric vehicle in the normal Toyota setting. And in order to facilitate that, they fit a external 12 volt driven oil pump here to provide the cooling and pressure that we need with the for the transmission fluid. So if we do a quick little search here on our old friend eBay, we come up with this thing. And this is indeed a oil pump for a GS450H gearbox. You'll see it's got this flange that bolts up to this port here on the side of the gearbox. Now you probably noticed that it's got a bit of a price tag on it. Now the reason that this has a bit of a price tag on it is that it is a common failure part in the normal GS450H. And the reason is that inside this there are two bearings, I believe, and they wear out and cause the motor to basically destroy itself internally. There are several DIYs out there, I believe, also for people that have successfully replaced the bearings before the thing had catastrophically failed. So, for our application, because we're locking this input shaft, so if we can get you a picture, yeah. Because we're locking this input shaft and preventing it from turning, the mechanical oil pump inside the gearbox will no longer function, and thus we need this oil pump to be on our gearbox. So final piece of the puzzle then is where do we plug this thing? Because we've got this plug here on the end, right? There's part numbers and all that, but there's a plug on there and we need to connect to. And for that you need one of these, which is a oil pump controller. And what you get here is you get a socket where you connect your, the oil pump connects here, and we connect power and a little drive signal here. So what I recommend people to do when you're looking at these gearboxes for purchasing them, and I'm not going to get into the whole, how much they cost and stuff, that's kind of the subject for a different video, but what I will show you is that if we just do a basic search here, right, we say GS450H gearbox, okay, something like that, we're going to see them at, let's get rid of some of this crap, we're going to see them at various prices. Like this is the UK eBay, it's the one that I use because eBay never really took off in Ireland. So you'll see them here, like there's £350 all the way up to, they get to be a bit more. Sometimes you see them stripped off, you see the cables stripped off, there's an oil pump. And they're selling those pumps because they're a common kind of replacement part, and the breakers know that people need them, and so they're going to charge more. But if we take a look at this one, I just suspect, because there's not much by way of, oh yeah, there it is. Let me see if I can click on this for you. So in this case here, you can see that the oil pump is still attached. So that's an important thing that you need to go find yourself one of these that has the pump attached to it. So all this is very well, and I've blabbered on now for a full hour. So you've now gone out and you've got yourself one of these and you got yourself an inverter and you got the pump on there and you went and you grabbed yourself one of these oil pump controllers. These are pretty cheap. You get them like 50, 60 euros. So now you've all this stuff lying on the floor and you say to yourself, oh my God, like I've got wires everywhere, there's high voltages and the signals, and how do I tell this thing what to do? How do I tell this thing I want the car to go forward? How do I do all this? Okay. So, welcome to hour number 2 of this particular marathon. So I'm going to bring us back to the Wikipedia page here on the the wiki page on the Open Inverter forum for the GS450H inverter. Now it's titled the inverter, but it really encompasses the whole drive system. So basically everything that we've discussed. You can see here it's the inverter, transmission, oil pump, wiring harness, and so forth. Now, this is really fleshed out very well, and I have to say, I'm really pleased that people have contributed what they have contributed to it. Now, you will recall that we said that on the box on the inverter, we had this connector, and this is the data connector. So this is where we will send signals through these pins to tell the inverter to spin the motors in our transmission so that we can drive. So the question is, how do we go about that? So if we scroll down here, and again, there's a very good description of, again, it's kind of a shortened description of what we've been talking about. In fact, here is just to finish up, it's there's one of the guides here on how to do the oil pump bearing swap, and we seem to be in some kind of flicker mode. So there's a page there, it's linked on the wiki here for showing you how to do that particular bearing swap. So we now get to the point of, well, how do we connect to it? How do we send the signals to it? And what signals does it need? Now, at the beginning of the video, I said that there was a guy over on the DIY EV forum at least 5 or 6 years ago now that did a conversion based on one of these, and he had done quite a lot of extensive reverse engineering work on the signals and the connections. And unfortunately, that information didn't get shared out, so that had to be rediscovered again in fairly recent vintage. But we've got all this here now, and there's quite, there's quite a lot of info on here, and there's part numbers for the connectors and the pins and all this. So I'd highly recommend people that this is the place that you actually start. So if we look here, I'm going to click on this wiring diagram. Hopefully this flickerage goes away. Hopefully it won't be too bad on the final video. So, okay. What we've got here now is this thing that, this is really intimidating. Okay, I accept that. This is, we've got all these colors, we've got all these wires and symbols and numbers and stuff. But I'm gonna take this in pretty short or in pretty small parts for you, and I'm gonna hopefully get you less scared of this particular wiring diagram. And then we will go on to the actual VCU, or vehicle control unit, that will send the signals to it. So let's have a look at some of the big squares or big rectangles here. This one in the middle, okay? So this one in the middle, so let's start here. This one here, that's, my eyesight's not so good, but this is the inverter, okay? So this rectangle here, this is our inverter. That's the box that we were talking about. That converts our, I guess, our DC from our high voltage battery into AC to run our MG1 and MG2. This rectangle down here represents MG1 connections. This one, MG2. So we have the inverter, and I guess you could say we have the transmission here. Up the top we have this thing that says Hybrid Vehicle Control ECU. And this is the Toyota control module that sends the control signals to the inverter. Again, don't focus on all the wiring colors, just focus on this kind of rectangles here. Now, you'll see we got these signal wires here going from this motor generator MG1 up to the inverter, and similarly here back to the inverter. So the good news is that all of those you don't really need to worry about, because this is a plug, just a wiring harness plug. These are all low voltage signals, I should mention. There's no high voltage stuff here at all. This is just basic automotive wiring. There's nothing higher than 12 volts DC here. So we're going to start here with GMTG generator, which is what they call MG1. And we're going to see that GMTG is this wire here. And if we look over here at this one, MMTG is this grey wire. Well, GMTG stands for generator, motor, temperature, ground. Okay, generator, motor, temperature, ground. Motor, temperature, ground. In Toyota parlance, the generator is MG1 and the motor is MG2. So these two wires here, the red and the blue, the grey and the green, are the temperature sensors for the windings of MG2 and the windings of MG1. Now this little rainbow effect here, and likewise here, are called the resolver connections. And what is a resolver? Well, a resolver is a little device that runs, it's a little electromechanical device that runs on the motor shaft that sends a signal back to the control electronics in the inverter to tell it information about the position, speed and direction of the rotor. So how fast it's turning, in what direction it's turning, and what the exact angle in like between 0 and 360 degrees that it's currently at that particular, at I guess any moment in time. But We don't need to worry about any of that, because you put a plug into this and you put a plug into that and we're done. Okay? So let's look here. GND1 and GND2. Well, ground. Connect them to the vehicle chassis. Simple. We've got B2, plus B2 and plus B. They're just 12 volt signals. 12 volts DC. Okay? So all this blue madness here is just 12 volts DC. So let's look so far. We've got a wiring plug goes in here, brings these signals. We've got a wiring plug here that brings these signals. We've got a ground. We've got a 12 volts. That's it. Don't mind any of this, just interlock stuff. You don't need to worry about any of that. You can just leave them. So we've gone from this massively complicated disaster of a rainbow coloring to being a couple of plugs to bring these signals in, and a 12 volts and a ground. But Damien, I hear you say, what about these signals here with the black and the white cables? Aha. What you've got here are 4 pairs of cables. You see this rec plus, rec minus, clock plus, clock minus, HTM plus, HTM minus, MTH plus and MTH minus. This is how we communicate with the inverter. This is just a digital communication bus. It's called synchronous serial for those techies amongst you, but you don't need to worry about that stuff, okay? Because ultimately this is just connecting wires from the inverter to our VCU. So let's recap one more time, because I do not want people to get scared of this wiring diagram. We got a plug, brings the resolver connections from MG1 to the inverter. Plug that brings the resolver connections from MG2 to the inverter. We've got a ground. We've got 12 volts DC. Finally, we'll have the communication connection here. And that is basically it. That's the control signaling that you need in order to make this stuff work. Now, let's jump back into the wiki. And if we scroll down here, here is a list of the connectors, their part numbers, terminal pin part numbers, and everything else that you will need to connect to the gearbox. Obviously, ideally, if you could get a wiring harness with your gearbox, that would be ideal. Now, we're going to come down now to the control board. And what we've got is an open source VCU designed by me. Can be purchased as both partially populated and fully populated and tested boards. Now that needs to be updated because due to some recent changes, I am not selling these as fully populated anymore. They're being sold as kits, but we can get to that in a minute. The controller needs its own enclosure and terminals, and here's the part numbers for those. Now what we don't exactly have here at this point is a wiring diagram that shows you how to connect between the VCU, so the control board, and the inverter diagram that we just went through. So that's something that we're going to need to remedy. Okay, so we're on the EV-BMW web shop now, and we're looking at the Lexus GS450H VCM or VCU or whatever you want to call it kit. And what we've got here is a board that I've developed based on work by others that enables us to interface with the Lexus GS450H inverter and send it the commands that it needs in order to make the motors turn. That's, I guess, the simplest way to describe it. Now, like I think most of my stuff, this is an entirely open source project. So what does that mean? Well, it means firstly that you can go on to the GitHub website and you can go to my GitHub, and I've got quite a few, Jesus, I actually got quite a few repositories on here, but we'll go to the Lexus GS450H inverter controller repo, and what you will find here are all of the source files for this design. So that means if you wanted to go and make this for yourself, all of the information that you need is contained here. For example, if we click on the V2, you'll find the schematic of the PCB, the PDF of the PCB, PDF schematic. You'll find the design spark files, you'll find the bill of materials and the component placement files, you'll find the Gerber files, basically everything that you would need to build one, to troubleshoot one, to support it, and to add bits that you might like is contained in this, I guess, on this web page, in this GitHub repository, whatever you might like to call it. In the software section, there's currently these 6 files. And as I have added more features and learned things and that to them, they've got higher versions. Now in part 2 of this video, because I am going to make this into a 2-parter. In this first one, we really want to just break down the whole, what is it? You know, what are the components? How do we pull them together? How do we learn more about them? In the second part, I'm going to do a very, again, in-depth dig into the controller, and we will show you what each signal does, and hopefully correlate some of that to the software. So one of the things I want to point you to, though, is this controller V2 pinout. So let's go have a look at that. Alright, so if you grab that file and open it, this is what you're going to get. You are going to get a 2-page document like this. And what we do is we show you the front connector of the VCU. So this is the this is basically the pins that you will see, like when you build up this little kit. This is where these pins connect on the board. So this header solders to the PCB. I have a full video tutorial showing you how to build the kit. So what we then get is we get this header here. And there's two plugs, plug A and plug B. We give you the part numbers for, sorry, two sockets A and B. We give you the part numbers here for the plugs and the pins. And down here then we have a description of what each of these, of the signal that is attached to each of these pins. Now, what we need to do, and it hasn't been done yet, is to assign which of these pins, right, connects to what. And it's going to be a very important thing that I'm going to have to prepare for you for part 2. But what I want to do is I want to show you a little bit here on plug B, and I want you to see these signals here in particular. MTH minus, MTH plus, HTM minus, HTM plus, rec minus, rec plus, clock minus, and clock plus. Where did we see those before? And the eagle-eyed amongst you will have seen them in this picture here. We have rec plus, rec minus, HTM minus, or sorry, HTM plus, HTM minus. This is our interface. This is our synchronous serial interface here. So these wires, the whites and the blacks, connect to these pins on plug B on the inverter controller. And the inverter controller will then do things like take in a throttle signal. Maybe you have optional CAN on there if you want to control stuff with CAN. It'll take in general purpose inputs, like you might want a forward or a reverse. It'll take in a brake light signal so you can tell it when you're pressing the brake. And it will convert whatever that you put in there into the necessary signaling through those connections there to command the GS450H inverter. And up here then we have connections for the temperature sensors. So we've got MG1 temp, we've got the connections here for shifting the 2-speed hydraulic planetary gearbox. We've got the necessary driving signals for the oil pump controller, and a second CAN interface that we could use for communicating with a modern vehicle. And in fact, this is what I am running in that video that I showed you earlier. Now, in the next part, as I say, we're going to deep dive into this. But for the minute, what I want you to do is I want you to consider this design, so this board and the connector, to equate to this Toyota brain here, this controller, and it connects to our inverter box through these interface pins. What is it? 2, 4, 6, 8, yeah. So let's go back one more time here. We've our resolver connections that just plug from the gearbox into the inverter. We've our ground, we've our 12 volts, we've these connections here that go from the inverter to our VCU, VCM, ECU, control board, brain, whatever you want to call it. And that's it for the low voltage stuff, guys. That's it for the spaghetti wiring. So you're well on the way at this point to understanding what you need in order to get one of these Lexus GS450H gearbox and inverter systems working in your vehicle. Now, I'm not going to cover things like the cooling and the oil coolant and stuff like that. That's all basic automotive stuff. Here we'll see, as we described, the oil pump controller. Let me just turn off some of this stuff because I think this is causing some of the flickering to be going on here. So here we have the wiring diagrams and stuff, and again the VCU provides the drive signals to run the oil pump controller. So again, we have our harness connectors and a little bit of history there about the design. So I hope that this video will have, at least in some way, addressed kind of some of the myths and the bits of, I guess, misinformation out there about this. At this point, I've probably lost anyone who was even remotely interested in it, so I'm not going to rabble on for too long. As I say, I think I'm going to take this video and hopefully let this stand for a bit, and then I'm going to come back and we'll have a look at, as I say, we'll have a look at the connections in much more detail between the VCM, VCU and the inverter. I would encourage people to have a good read through the section here on the wiki article in particular, and on the let me just jump you straight over here. On the forum, we have a dedicated sub-forum here for the Toyota Lexus stuff, and there's a dedicated support thread here where I'm trying to build up again as much info as we can on here for the controller and so forth. Now, this is another video that I did prior to fitting the Lexus drive system into the E65 7 series. So what I want to do here is I want to show you a few, I guess, stills from this, and it will hopefully help to illustrate some of the points that we've just discussed around the wiring diagrams and so forth. So first of all, let's have a look at this plate here. So we've got this piece of flat steel bolted to the front of the gearbox, and we've got a spline coupling that fits onto the input shaft. And what this is doing here is it's providing the function that we described earlier of preventing the input shaft in here that would normally be connected to the internal combustion engine from rotating. So that can no longer rotate. Thus, the torque from MG1, which is in this part of the gearbox here, is directed through MG2 out to our spinning prop shaft flange here. You will see on the chair here, this is the inverter, this is the box. You'll see we've got our two orange cables plugged into this here. See, these two thinner orange cables here are the, in this case, the quote unquote high voltage battery, You're seeing this running on, I think it was running on at this point at maybe less than 100 volts or something like that. This guy sitting on top of the gearbox here is the oil pump controller. You can see this black cable here is leading down underneath here into that oil pump that's currently on here. The oil pump controller just has a ground, that's that brown wire there. It's just going to a 12 volt battery ground. It's got this blue wire, so you'd kind of snaking around this way. It's going to a 12 volt battery positive, and the little PWM signal, I can't really see the wire, I think it's this one, that's going to the VCU. So this is a real life, I guess, bench test, floor test, of the system here. I'd encourage you to have a watch of this video. It's not my finest hour in terms of filming prowess, I would say. Not that I have many of those. This was where I attempted stomach cam with a GoPro, so not exactly my finest hour, as I say. Okay, in this still here, you can probably have a better view of how we have our plate bolted onto the front. As I say, there's 100 different ways to do it. I'm just doing this with the tools and skills that I have to hand. This here is I'm making a mount here for the inverter and a few things like that. But you'll see there we've got wiring harness stuff, and this is before I stripped out the harness, because there was just an absolute, I got the whole gearbox harness and there was all of this stuff here, and there was a myriad of wires in here that we simply didn't need. So you'll see all these plugs here that aren't connected to anything. That's because, well, there's nothing for them to connect to, just for the purposes of running our gearbox here. Alright, now I guess this is really kind of it, as it were. You'll see I've got the inverter mounted here on top of this professionally welded system here that's bolted to the bell housing. This you'll see here is the plug that has the connections that we were describing that go to the VCU and the resolver connections on the gearbox. And again, this is when there was a lot of extra wiring. You'll see I've even got some of it chopped off down here, because there is actually, you know, not that many wires that you actually need. So again, what you'll probably see here is, if we can recognize some of this, these wires here, so these ones here will be some of the screened wires that are going down to the resolver connector. And I think, yeah, you'll see these ones here that are sneaking up onto the bench. In the black here will be the signal wires for sending the data to the inverter. Now, a couple of points, folks, okay? The inverter is quite dumb as these things go. Number one, it does not care what the DC voltage that you apply to it. It can be anything from 12 volts, and the motor will, you know, turn, but quite slowly, all the way up to, as I say, that, you know, theoretically maximum 650 volts. Or as we did in the GS450 or in the 7 series, we went for, you know, 360 volts, and it's perfectly happy with that. So that is what you're seeing there, kind of a bench test of what would ultimately go in the car and make that car drive as we saw in the previous video. So this is what you would need if you were to want to use this. Now obviously you don't need to mount the inverter here. This was a convenience fact. It's just in the E65 there was just a space here that we could slot that guy into. Okay, so there's one more topic that I want to cover. So this is another video here where you're going to see basically what we just saw on the floor in the shed installed in the car, and the car just, you know, moving forward and back a few feet just as a proof that all the signal cabling and stuff was working. But the question that we need to address is how do we get the high voltage from the battery, so be it our, you know, whatever 360 volt battery, into the inverter? Well, your first initial thought would be, well, this white plug here is where the 288 volt battery in the Lexus would normally connect. So what have I got? What are these brass connectors here, and why have I got these two big kind of black and red cables going in through this hole in the side of the inverter? Why am I not just connecting directly in to where it was designed to go within the within the normal hybrid application? So we're back on the wiki page. We're going to have a look at this section here, which says the GS450H converter. Recall, this is the part that, as it's described here, originally used to step the 288 volt battery pack up to 650 volts. Now, we've already explained why we don't need the full 650 volts in here. I'm not going to go back on that. But the problem is that this unit is rated at 30 kilowatts. Now, you'll recall earlier that we were pushing about 120 kilowatts into our inverter. So if we were to connect our high voltage battery in here into this original connector, we could only push about 30 kilowatts before we would burn out the buck boost converter within the casing. So fortunately, there's this little access port on the side of the inverter. Let me go see if I can get you a picture of that. Alright, so we're back with our old eBay friend here, and we've got a picture here. Unfortunately, of course, it's rather fuzzy. But what we've got here is, this is our connector that we were showing you on the video where we would normally connect our hybrid battery. And down here you'll see this black area, and there's a bolt here and there's a bolt here. Now if we remove those two bolts, we take the metal panel off. It's a little plastic cover that sits here. Now if we pop the cover out, what we get are two M6 bolt terminals that are recessed in the inverter. Now those terminals give us direct access to the main inverter DC bus in here. So we bypass this converter stage and go directly into the inverter. That is what we're doing here with our two brass posts. Now you can use any kinds of different connectors that you wish. But what that lets us do is to connect our much heavier gauge cables in here directly to where we need the power to be, and bypass the bypass this converter stage. Now, as a graphic demonstration of this 650 volts bullshit, and I'm sorry, I just have to say it, what I've got here are two 20 volt batteries. So this was just 40 volts DC that I was feeding in through. We've got a black cable, we've got a red cable, and I just stuck a fuse in there. and they're going in through the red and the black cables straight into the inverter here. You can see the cables coming up here. These are my signal cables going to the VCU. There's our oil pump controller. And this was capable of moving the car around the workshop. Not very fast, because we just had 40 volts, but we could shunt the car around the workshop and just prove before we went putting the full battery in here and cooling systems and all that, that we hadn't screwed up the wiring or something else, that it would just move the vehicle physically. So again, this is just, and I would encourage people where they can to watch some of these videos, because I guess there's bits of information in there that will be useful to you. But I wanted to just grab a few of the bits and kind of stick them in here into this particular video, so you can see some of the stages that it takes to basically fit one of these powertrains, I guess would be the right way to say it. Now, in this case here, we've gone a step further. You'll see we've got our hoses attached here now to the inverter. So we have a full cooling system here with the full front pack in. This is what, 1, 2, 3, 4. This is 12. To embarrass myself on camera here now. So this is about 230 volts. Something like that from the front. This was just the front pack. This was normally occupied by the V8 in the E65. So we're using the full engine bay, I guess, here to put a battery in that normally you couldn't do with a traditional motor and gearbox conversion, because you'd be, you'd have the motor here and the inverter here, and you just wouldn't have, you might have a little bit of space here, but you certainly wouldn't have all of this available to you. And you'll see here that even though in this case we were unloaded, what I was doing was I was basically seeing where I would run out of RPMs with my 230 volt pack. And I just encourage you to watch this particular part. You can fast forward. It's about 10 minutes in, and you'll see here that we were happily spinning up, coming up there in about 3,000 RPM. I don't know if we went any. Oh yeah, we did go a bit further than that. Yeah, I mean there we were going up. We were passing 4,000 revs. The tacho in this case is being driven by the MG2 RPM. With the gearing that we had at the time, that was coming up about 50 miles per hour. And the so what I did, and it absolutely, I may not have had to do this, but I did it, was I changed the differential. I put a 730D diff in there, and that made it, helped the gearing. And that's what I mean, like it's actually easier to, sorry about the flickering here, it's actually easier to change gearing, than it is to be running at a voltage that's quite hard to work with. Alright folks, so what I'm going to do is I'm going to round this one up here. I hope that this has served as some kind of an introduction to you. Pulled together, I guess, what's been a lot of development, a lot of testing we've done over time now with this particular gearbox. Do join me for part 2, where, as I said, we will get seriously deep into this whole VCU thing. And I would encourage people that if you can, please contribute, get involved here on the Open Inverter forum, on the be it on the forum or, you know, with the wiki and stuff like that, and try to get as much information as we can out there. That'll make this easier for people to get into. So folks, hope you've enjoyed it. It has been a long one. As usual, don't forget to dislike, unshare, unsubscribe, and don't recommend this crap to your friends. Now, we'll be back for part 2. Don't know when that'll be, but I'll try to get it as soon as I can, just to keep a bit of momentum on this. So do check the links in the description for the usual suspects in there. And until next time then, happy Lexus Gearbox purchasing.